Welcome back to Mr. Hassan's Maths channel. I'm now answering question number 16. This is actually from the Pearson's Edexcel International A-Level S1 textbook from chapter 5. It's the chapter 5 review exercise. It's question number 16. Chapter 5 is about correlation and regression. This is on page 122 of the book. Okay, so that's where this question is from. Now, this question here, part A of the question, I don't think it will be a question that you would be asked in the exam, but as the student has asked me to go through, I will go through it anyhow, because this involves some dealing with something called sigma notation and how to manipulate it, which we haven't done in P1 and P2. We get into that if you do further maths. So, but I'll still go through it. It's not really that difficult. So basically, we're told that a geography student collected data on GDP per capita, means like the gross domestic product per capita, per person in the country, which is denoted by X in thousands of dollars, and infant mortality rates, which is denoted by Y, which is basically the deaths per 1,000 of the population, from a sample of 8 countries. She coded the data using P equals X minus 10 and Q equals Y over 20 and drew a scatter diagram of P against Q. Actually, it's Q against P. Okay, here's Q against P. Alright, so I think that should say Q against P. That's what's drawn. Anyway, unfortunately, she spilled coffee on her work, and the only things still legible were her unfinished scatter diagram and a few summary data calculations. Okay, so, all right. So show that SPP equals SXX. All right, so now, they've given us some data here. The sum of Q squared, which is basically the sum of all the value, basically all the Q values, okay, squared and then added together. The sum of Y are all the original Y values. Okay, all the original Y values added together. That's the sum of Y. And SPQ, SXX, SPP, they're basically a measure of the variance, how the values of P vary with the values of Q, how the values of X vary within itself, how and so on. That's what it's basically to do with the variance. And we have a formula over here. SXS, XYY, SXY. These formulae here help us to calculate the value of the these variance kind of values here. All right. So in this question, the first part of the question tells us show that SPP equals SXX. So SPP, if we look at the formula that we've been given, let's see if I've got it here. Yeah, so this is the formula from the other page. This is for SXX. So let's relate it to P. Basically, I'm going to be concerned with this part here. This is equal to the sum of, I'm going to use P instead of X now, the sum of P squared, okay, minus the sum of P all squared over N. And I've got to show that this is equal to SXX. Now what I'm going to do is I'm going to use the coding that they gave us. They told us that P is equal to X minus 10. So I'm going to replace the P in both of these with X minus 10. So I'll say that this is equal to the sum of, instead of P, I'll put X minus 10. So that's X minus 10 in brackets squared minus, and then I've got in brackets the sum of X minus 10 and all of this squared. Okay, what's the difference between these two? This is like where you square the p-values and then add them together. And this is where you add the p-values and then square the result. So that's the difference between these two, and this is over N. Okay, so now let me just expand this. This is going to be the sum of, if I expand this bracket, I'm going to get X squared minus 20X plus 100. Okay, squaring this bracket. So you're going to X minus 10 times X minus 10, which will give you that. And what I'm going to do here is before I square this, I'm going to like expand this in a way. So I know that the sum of X in bracket, the sum of bracket X minus 10 is the same thing as writing, I'll put it in a bracket, the sum of X minus the sum of 10. Okay, now the sum of 10, I'll write it like this for now. Okay, this has to be squared over n. Now, what is the sum of 10? It's basically I have to add 10 to itself. How many times? The number of entries that we have, which is, in this case, this is 8. Well, we'll just call it n for keep it general n. Okay, there's n entries. Okay, just in general, keeping it general. So the sum of 10 is like 10 times n. 10 times the number of times you have to add it to itself. So that's, again, this is something which we haven't really studied in P1 and P2. This is something that comes in further maths, how to deal with this sigma notation and how to split it up. Although kind of in P2 we kind of looked at it, like for example, I can say the sum of this is the same as saying the sum of x squared minus the sum of 20x plus the sum of 100. I can like split it up into the 3 different parts. And this, what I'm going to do now is I'm going to square this bracket. So this is, I'll keep the bracket here. So this is going to be this is basically all of this squared. So the sum of x all squared, like this, sum of x all squared. And then I'm going to have 2 times the sum of x times the sum of 10. Remember, the sum of 10 is equal to 10n. So this is like this. This is like 10n. So I'll replace this with 10n. So this is going to be minus, you're going to have 20 times n times the sum of x, because you're going to have 2 times this times that. Okay, the middle term. All right, when you do the sum of x minus the sum of 10 squared. Remember, this is 10n. So it's 20n times the sum of x. And then you're going to have to square this. You're going to have plus, and you're going to have, what I'll do, just to make it clear, I'll just I won't miss out that step. So I'm just going to write this first as the sum of x minus 10n. As I mentioned, this is like 10n. Okay, because this is the sum of 10. All right, you have to add 10 to itself n times the number of entries that you have times. Okay, so that's why that's 10n. All right, so now let me just expand that without missing that step, just in case it's confusing for some of you. So that's 20x plus the sum. Now remember, as I said, the sum of 100 is like saying 100n. So this is plus 100n. Then I've got minus. Now let me just expand this bracket. So as I said before, this is like the sum of x all squared. Okay, minus, you're going to have the sum of x times minus 10n times 2. So it's minus 20 times n times the sum of x. And then I've got to square the last term, so plus 100n squared. And all of this is over n. Okay, so I'm going to have this. Let me just do something to make it a bit easier. This is root 20, no, not root, sorry, sum of 20x plus 100n. Okay, now what I can also do with this, by the way, I can rewrite this as 20 times the sum of x. The sum of 20x is the same as 20 times the sum of x. Okay, now this is going to be minus. I'm going to now keep this bracket here, but I'm going to split this into 3 separate fractions. Okay, it's 3 separate fractions. So this is going to be the sum of x all squared over n minus 20n times the sum of x over n plus 100n squared over n. So now I have the sum of x squared minus 20 times the sum of x plus 100n minus the sum of x all squared over n. Minus and minus is plus. This n cancels with n. That's 20 times the sum of x. This n cancels with the n squared, leaving you with n. You got minus and a plus, which is minus 100n. Now you'll notice what happens now is things cancel out. Minus 20 times the sum of x plus 20 times the sum of x becomes 0. 100 times n minus 100 times n becomes 0. So you're left with the sum of x squared minus the sum of x all squared over n, which is exactly what s double x is. The variance of x with itself. Whoops. Taking the wrong thing down with me. That's better. Okay, so that is exactly what this is. If you look here, they're exactly the same thing. Yeah. So we can therefore say, this is equal to sxx. Therefore we started this with SPP, and we found we ended up with SXX. So therefore SPP is equal to SXX. So we've shown that very clearly in this question. Okay, so there is part A. Now part A, I doubt very, very much you would get a question like this. Okay, but I've just done it because one of the students has asked me to. And so I guess it's better to be safe. But we dealt with how to manipulate this using certain laws of how to deal with the sigma symbol. Okay, so if you have something like the sum of 100, it's like 100 times the number of times you have to add it together. Okay, so that's n here. All right, so now let's go on to part B. It says find the value of the Pmcc, the product moment correlation coefficient between P and Q. Now we're given this formula in the formula book. This is what the formula for the Pmcc. Pmcc, okay, is given the symbol R, which is how x and y vary over the root of how x varies with itself times how y varies with itself. In this case, we've got to find between P and Q. So for us, what they want to find is SPQ over the square root of SPP times SQQ. Now, what we found already in the last question is, or we just mentioned that SXX is the same as SPQ. So I know what SPQ is. And we know what we know what SPQ is, and we also, this is SPP I'm talking about. This is what we just found in the last question. SXX is the same as SPP. Okay, that's what we just worked out. Excuse me for that. SPP. So we know what SPP is. We know what SPQ is. We have to find what SQQ is. SQQ. That's what we have to find. Now, let's look at our formula book again. Let's look at the formula that we just used before. Have I still got it here? Yep. Okay, so this formula will come in useful for SQQ. So we can say SQQ is going to be, if we look at this, the sum of Q squared minus the sum of Q all squared over N. All right, we know N is 8 because there's 8 entries, 8 countries. We know the sum of Q squared. What we got to find is the sum of Q. All right, the sum of Q. Now, we know that Q is equal to y over 20. So the sum of Q, therefore, is going to be the sum of y over 20. So the sum of Q is going to be the sum of y, which we know, which is 491 divided by 20.